Imagine building the coldest, quietest ear you can. Not a human ear, not a microphone, a machine. A machine so sensitive that its own warmth could ruin everything. So you cool it down until it's almost as cold as the oldest light in the universe. You lift it above the clouds, above the weather, above most of the atmosphere. You send it into the sky under a giant balloon. You tell it one job: listen, not for aliens, not for screams, not for ghosts hiding between galaxies. Just listen for the faint radio glow of the universe, the old background, the leftover warmth, the quiet static behind everything. And the machine listens. The universe does not whisper, it roars, not sound. That part matters. Space is not carrying a giant across the void. This is radio noise, invisible light, low frequency radiation, the kind of thing your eyes cannot see, your ears cannot hear, and your phone would only understand it if it were built like a tiny space laboratory with commitment issues. But still, the word roar stuck because scientists expected a background. They expected static, they expected signals from our galaxy, from distant radio galaxies, from north sources spread across the sky. They did not expect this much. The universe was louder than the math said it should be. And this is where the story gets good. Because a mystery is not always a locked door in a haunted house. Sometimes it's a graph. A graph where one line should sit neatly on top of another. And instead, the line climbs up and says, no, let's go back. In 2006, NASA's Arcade 2 experiment flew on a balloon from Palestine, Texas. Arcade stands for Absolute Radiometer for Cosmology, Astrophysics, and Diffusion Emission, which is a very official way of saying we built a cosmic static detector and gave it a name that sounds like it should have pinball machines. Arcade 2 was designed to measure faint radio signals from the sky. One thing scientists wanted to understand better was the cosmic microwave background. That is the afterglow of the Big Bang, the oldest light we can observe, not the beginning itself, but a baby picture of the universe when it finally became transparent enough for light to travel freely. This ancient glow fills the sky in every direction. It is almost perfectly even. It is cold now, about 2.7 degrees above absolute zero. And Arcade 2 was designed very cleverly. If the instrument itself is warm, it can glow in radio waves. That is a problem because then you're not measuring the universe. You're measuring your own equipment being dramatic. So Arcade's receiver was cooled with liquid helium, more than 500 gallons of it. The instrument was brought close to the temperature of the cosmic microwave background itself. That way, the machine would not shout over the thing it was trying to hear. It is like trying to listen for someone breathing in the next room. So you first have to convince your refrigerator, your ceiling fan, your phone, and your own nervous system to stop auditioning for a percussion band. Arcade went up. It looked at the sky. It compared the sky to an internal calibration target. It tried to measure the absolute brightness of the radio universe. And when the data came back, scientists had a problem. There was extra radio brightness, more than expected. They could subtract the cosmic microwave background. They could estimate emission from our Milky Way. They could estimate the contribution from known radio galaxies. And after that, something was still there, a leftover. A radio glow that should not have been that strong. That leftover is what people started calling the space roar. Now, this is where we have to be careful. This does not mean there's one giant object out there yelling. It does not mean a hidden civilization is broadcasting a universal ringtone. It does not mean the cosmos has a mouth. Sadly or thankfully, depending on our sleep schedule. It means the radio sky appears brighter than expected after known resources are accounted for. That sounds less flashy, but it is actually more unsettling. Because if one strange thing makes a signal, you search for the strange thing. If the whole background is too bright, the mystery is everywhere. It's not a footprint, it's a fog. So scientists ask the obvious question. Maybe there are more radio galaxies than we thought. Radio galaxies are galaxies that are bright in radio wavelengths. They often have active supermassive black holes at their centers. These black holes can launch jets of particles across enormous distances. Those jets can glow in radio waves. So maybe the space road is not one mysterious thing. Maybe it is the combined murmur of countless faint galaxies we have not counted properly. That would be neat. That would be tidy. That would let everyone go home and eat lunch. But here is the problem. To explain the excess using ordinary radio galaxies, you may need far too many of them. Not just, oh, we missed a few. More like, did the universe secretly open a warehouse? The arcade team's own discussion points out that known populations of radio sources do not seem sufficient to explain the excess. NASA quoted one team member saying that if radio galaxies were responsible, you would need to pack them into the universe absurdly densely, which is such a beautiful scientific insult. It is basically the astrophysics version of be serious. So, if known radio galaxies were not enough, what else could it be? One possibility is that the faintest radio sources behave differently than we expect. Maybe there's a population of very faint galaxies that surveys have not resolved yet. Maybe early galaxies made more radio emission than our models predict. Maybe some old population of stars, black holes, supernova remnants, or energetic particles left behind a background glow. Maybe clusters of galaxies merging over cosmic time stirred magnetic fields and particles enough to create extra radio emission. That idea has been studied too. There are also more exotic possibilities, and by exotic, I mean the kind of physics that walks into the room wearing sunglasses indoors. Dark matter, new particles, dark photons, unexpected processes in the early universe. The kind of ideas that are exciting but must be handled with oven mitts, because we do not know yet is not the same as therefore wildest answer wins. Science is not a game where the wildest theory gets a trophy. It is more annoying than that. You need evidence, you need predictions, you need other experiments to agree. You need the explanation to survive all the boring questions. And boring questions are where weak mysteries go to die. Could the signal be from our own galaxy? Could the Milky Way's radio glow be more complicated than expected? Could there be an instrumental effect? Could calibration be wrong? Could foreground subtraction be tricky? Could old radio surveys and new balloon measurements be disagreeing in some quite technical way? These are not party questions. Nobody hears foreground modeling uncertainty and thinks, finally, romance. But these are exactly the questions that matter, because the sky is messy. Before you can say the universe is roaring, you have to make sure Earth is not humming. You have to make sure the Milky Way is not spilling radio light into the measurement. You have to make sure the instrument is not fooling you. You have to make sure the signal is not a shadow created by the way you removed other signals. This is why the space road is not a clean, simple monster under the bed. It is more like hearing a sound in a huge old house, then realizing the house has pipes, winds, floorboards, neighbors, and your own heartbeat. Still, after all that caution, the excess remains interesting, because it was not just Arcade 2 by itself. The analysis combined Arcade data with other radio measurements and Fires measurements of the cosmic microwave background. The paper describes a significant residual signal beyond what can be explained by CMB and the integrated emission from known radio galaxies. That is the edge. That is the little splinter under the universe's skin. Something in the radio background appears brighter than expected, and no explanation has become simple, universally accepted answer. Now, here is where I love this mystery. It is not loud in the way humans understand loud. If you were floating in space, you would not hear it. There's no air to carry the sound. Your ears would be useless. Also, you would have several more immediate problems, and I recommend not testing this personally. But if you had the right instrument, tuned to the right radio frequencies, sensitive enough, cold enough, calibrated enough, you would detect a kind of cosmic static, a background, a glow, an invisible noise. And somewhere inside that radio darkness is an excess, a too much. That phrase is underrated, too much, a small phrase with giant consequences. Too much radio light, too much background, too much signal from sources we cannot fully identify, too much universe where the model expected quiet. And that is the real hook. The universe does not have to break the laws of physics to scare us. Sometimes it only has to be slightly brighter than expected, a little warmer, a little louder, a little off. That is how science often finds the edge of what it knows, not with a huge sign saying new physics here, more like a stubborn number that refuses to sit down. Think about it. The cosmic microwave background was itself once a strange noise. In 1962, scientists detected a persistent microwave hiss. They tried to get rid of it. They checked the equipment, they cleaned the antenna. They blamed everything reasonable, but the noise stayed. That noise turned out to be one of the most important discoveries in cosmology, the afterglow of the early universe. So when scientists hear an unexpected background, they do not automatically panic. They get suspicious. Suspicion is one of the science's love language. The space roar may turn out to have a normal explanation. Maybe future radio surveys will find the hidden source. Maybe better maps will show that foregrounds were trickier than expected. Maybe some population of faint objects will politely step forward and say, "Sorry, that was us." But until then, the mystery sits there. A radio glow spreads across the sky, too strong to ignore, too uncertain to explain, too interesting to leave alone. And there is something almost poetic about the way we found it. Now with a giant telescope on a mountain top, now with a spacecraft traveling beyond the planets, but with a balloon carrying a frozen instrument above Earth. A little machine lifted into the dark, trying to listen to the oldest light. And instead it hears a hidden background. Imagine that scene. Below it, Earth is glowing with cities, storms, radio stations, cell towers, radar satellites, and all the noise of living things that cannot stop broadcasting. Above it, the universe, silent to human ears, ancient, cold, gigantic. And somewhere in that silence, a radio roar. The weirdest part is that the roar is not necessarily coming from one place. It may not point to a single object. It may be woven through the background. That makes it harder to make a thumbnail, yes, but it makes the mystery better. A monster is one corner is scary. A mystery in every direction is worse. Because if the whole sky is involved, you cannot simply turn your telescope and say, "There it is." You have to understand the background of reality. That is a bigger job. That is the kind of job where universe looks at us and says, "You bought one balloon, cute." But that is how we learn. One instrument, one mismatch, one little refusal from the cosmos. The space road reminds us that the universe is not just stars and planets and pretty nebula pictures. It is also backgrounds, fields, radiation, signals, old light, hidden light, noise that is not noise, information arriving from distances so large that the human brain just turns around and walks into a wall. And maybe that is why this mystery feels different. We are used to asking what is out there: a planet, a black hole, a galaxy, a wormhole, a white hole. Something with a shape, something we can point at. But the space roar asks for a more slippery question. What if the mystery is not an object? What if the mystery is the background? What if the thing we missed was not hiding in space, but spread across it? Because that changes the feeling. It is not like finding a strange footprint in the snow. It is like realizing the snow itself is glowing. So where does that leave us? With several possibilities. Maybe there are more faint radio sources than expected. Maybe part of the answer is more boring. Maybe part of the answer is not. And maybe the most honest sentence in all of science is still, we do not know yet. But say it properly. Not we do not know like a dead end. Say it like a door. We do not know yet. And that yet is where everything lives. The telescopes, the papers, the arguments, the better instruments, the late nights, the revised models, the scientists staring at a plot and quietly ruining their own weekend. That is the good stuff, because universe is not finished surprising us. It does not care how confident our diagrams look. A roar that nobody can hear, but our instruments cannot ignore. And maybe that is the strangest part. The universe may be silent to us, but silence does not mean empty. Silence does not mean salt. Silence does not mean nothing is happening. So here is the question I cannot stop thinking. If the universe has been roaring this whole time and we only noticed when we finally rose above our own noise, what else is already shouting at us, waiting for us to become quiet enough to hear it?